All right. So we're starting off Unit 8 today. We're looking at coordinate geometry in Unit 8. Coordinate as in the coordinate plane. So we are talking about graphing things. All right, in Unit 8, we're talking about coordinate geometry. We're talking about graphing things in the coordinate plane and the different geometry things that we've been talking about. So we're going to review a lot of formulas. Some of this is content that normally you would have gotten in Algebra 1. And so depending on where you were with that in your Algebra 1 class last year, some of it may be a little bit tougher to remember. But first thing we want to talk about is slope. We're going to use slope a lot in this unit when we talk about different lines. Okay, you remember what slope is? Does anybody remember what the slope of a line is? Nod. Okay. The slope of a line, and if you need to like turn your chairs at all to face this, that's fine. The slope of a line, there's kind of a technical wording of this. It's the rate of change for a linear equation, okay? So it's the change in one variable over the change in the other variable. It's a way of comparing how the two variables are changing as and how they're related, okay? And we talk about that as rise over run, okay? There's actually a formula we use for slope that we'll get to in just a minute. Slopes can be positive when a line is going up and to the right. That's a positive slope. If it's going down and to the right, that'd be a negative slope. But they can also be zero or undefined. We're going to look at special cases when the slope would be zero or undefined. Okay, when the slope is undefined, when you're doing this fraction rise over run and you have it over zero, that's when you get an undefined slope. When there is no run, it's all rise, because you can't divide by zero, right? You guys have heard that before? You can't divide by zero in a fraction. It doesn't work mathematically. It's impossible to do. It's undefined. If you're given a graph, you're going to simply count the rise, the change in the y values, and count the run and write it as a fraction. And we always write slope in simplest form, meaning fully reduced. We want to reduce the fraction completely. Okay? A lot of kind of wording here, but really as we go and do the problems, it'll be a little more easy to understand. So the slope formula, and this is a formula you'll need to know, is this, okay? M equals y1 minus y2 over x1 minus x2. And actually that could go backwards from that. You can put the 2's first and the 1 second, doesn't really matter. But variable m is used to represent the slope. That lowercase m is used to represent slope. X1 and Y1 should be just from the first coordinate you see, the first point. Okay, so whichever one the first one is, that's kind of what we do. X2 and Y2 should be from the second set of coordinates. Okay? So as we look at our examples, we want to find the slope of each segment by using that slope formula. We want to subtract the y's over subtracting the x's, and you really just want to keep them in the same order. Okay, so when I see two ordered pairs here, I'm going to call this first one x1, y1. That means x1 is -2, y1 is 5. You guys have done this when we did distance formula. And by the way, that's going to come up in this lesson too. We're going to review all these formulas we've used in the coordinate plane. That means B are the coordinates x2, y2. So to find the slope, we're just going to use this formula you see above. Okay, we're going to do the difference of the y values. So we're going to do y1 minus y2. So I start with 5. When I do minus -1 like that, I really need to write it in parentheses because you're doing a double negative. Minus a negative. What does that turn into? Plus positive. That's right. Okay, so even the top part of that, without writing the bottom, I'm going to change to 5 plus 1. Now we do the same thing for the bottom values, the x's. The x's go on bottom. We're going to do -2 minus 6, which stays kind of -2 minus 6. And then we can reduce this, simplify it. What's 5 plus 1? 6 over what's -2 minus 6? -8. Now, when one of those numbers is a negative, only one, that means your fraction is a negative. We will have a negative slope. So I'm just going to put the negative out front. I'm not going to put it in top and bottom. I'm just going to put it out front and not worry about where it goes. Okay? But we can reduce that. You can divide 6 and 8 by the same factor. What can you divide 6 and 8 by? 2. So what does that reduce to? 3/4. So -3/4 is your slope. So for every one it goes down 3, it's going to go over 4 to the right. Because it's a negative slope, it's going down and to the right. Okay? I want you guys to try these next two. Try these next two on your own, and we'll check those answers. Okay, so as you look at these, on this one, you should have gotten, the slope of this GH line should be 5/2. Did we get 5/2? We may not get 5/2. Okay, for GH, we do -3 minus 7. That becomes -10, right? And then on the bottom, we do -11 minus -6, turns it into plus +6. That is not right. You caught my mistake, right? What'd I do? I just added wrong. Let's fix that. Okay, -11 plus 6 is 5. So that's 10/5, which is either the fraction 2/1 or just 2. Sorry about that. So 2/1 or just 2. Okay. If the fraction is over 1, remember you can just write that as a whole number. But if we were graphing these lines or looking at the graph, we would need to understand that over 1 is my run. So you are going to go up 2, but then you're going to go over 1. You're not just going to go up 2. But the next one over for XY, you run into a problem, don't you? The x coordinates are both the same. That means these x coordinates are lined up together, as we will look at with our other kinds of lines that we look at today. These two lines, or these 2 points, are directly over each other. They have the same x coordinate. So when you try and subtract the x's, you don't get anything. You get 0. 9 minus 9 is 0. When 0 is on the bottom of a fraction, that is undefined. So we either say that this is undefined, or we say there is no slope. No slope is not the same as 0. No slope means undefined. That's one of our possibilities here. Okay, slopes can be positive, -0, or undefined. That's what we just got. So for this last one, let's do our slope together there. We're going to do the difference of the y values on top. -3 minus -3 turns into +3, right? But then on the bottom, we have -7 minus 0. This time, 0 is what we get on the top of the fraction. We get 0 over -7. That is not undefined. That we can do. You can do that in the calculator. 0 divided by anything is 0. Okay? So here's what I want you to understand as we go through this. When we look at our graphs, an undefined slope is always going to be a vertical line. Because the x values are always the same, they're going to line up like that. A 0 slope is always going to be a horizontal line because the y values are the same here. Okay? So we can do the same thing using graphs. So it's a little bit easier with graphs because we can just count. Okay? So what we're going to do with our graphs, we're going to treat each line as the hypotenuse of a right triangle. We're going to treat each line as the hypotenuse of a right triangle. So for this first one, to find the slope, we're going to start with 1 point. I usually go left to right. Okay? I go left to right, and I always do my rise first. Rise goes on top. Okay? So I always do rise first. So I'm going to do a segment of my rise up to the level of where that other b value is. And then I'm going to do my run. And I'm going to make that right triangle from exactly one point A to the other point B. And that creates a right triangle. I'm just going to count the lengths there. Okay, we count the spaces. So from A up to where B is vertically is 1, 2, 3, 4 for that side of the triangle. And then from that point where A is over to B horizontally, 1, 2, 3, 4, 5. Now we can do our rise over run. What's the difference of our y values? How far apart are A and B vertically? 4, right? Okay, our rise is 4, and it's up 4, right? Going from A to B is up, so it's positive 4. And then going from A to B, left to right, that's still positive in the x direction. So our run is positive 5. Can that be reduced? That's our slope then. 4/5, up 4/5. Let's try another one. When I do these, M and N, I can't make that a hypotenuse of a right triangle with rise and run. I'm going directly up. I'm counting up 1, 2, 3, 4, 5, 6. My rise would be 6, but my run doesn't go left and right, does it? My run is 0. So what's my slope? Undefined. Good. Okay, but from P to Q, there's a slant to it, so I can do a right triangle. I'm going to start with P. I'm going to drop down and then go to the right. So what is my rise from P down to Q? -3. Good. We count down 1, 2, 3. So that's a -3 because we're moving down. But then we still go to the right. 1, 2, 3, 4, 5, 6. That's still a positive. Now that makes sense to us, right? That only one of those should be negative, because remember the slope, you can tell it's going down and to the right. We know that's a negative slope. If I had both negatives on rise and run, they would cancel as a positive. We don't want that. So only one of these is a negative, down 3 to the right 6. I always tend to make my rise my negative. I always go left to right. That way I don't have to worry about the bottom number being negative. But that will reduce, right? What does that reduce to? Negative -1/2, -1/2, right? Good. Okay, now do you guys get some of these where you can just look at them and know what they're going to be? What's the slope, Braden? 0, right? Because there's no rise. It's all run. Okay, it'd be 0 over a run of 3 from J to K, which is just 0. Good. You guys get that. Horizontal lines will always have a slope of 0. Vertical lines will always have an undefined slope. All right, let's go ahead and turn the page. All right, now we're going to look at what we call linear equations. And there's 2 different forms we're going to look at for linear equations. You guys might remember, you probably remember the first one really, really well. That second one you might not remember as much. But there's 2 forms. One of, and I apologize for the font. Some of the font on these, that's a slope intercept. And that squiggle down there is the word form. That actually is of words, not just a decorative little pattern. Okay. So the first example we have is slope intercept form. Okay, this is slope intercept form. Y equals mx plus b. Okay, y equals mx plus b. Where m, what does m mean? What does m stand for? We just used it on the previous page. What? Slope. Okay, and then b is what we call the y-intercept. Okay, now, if an equation is written in slope-intercept form, the coefficient is the number that was plugged in for m, or in front of x, and that is the slope. Now, this other number b is the y-intercept. That is where the line crosses the y-axis. Okay, it's where the line crosses the y-axis. So this is where it's really easy to graph these in slope-intercept form, because you start with plotting the point B on the y-axis, whatever that number is, put it on the y-axis, put a point, and then use your slope, rise over run, to get a second point, connect them with a line. But we have another form called standard form that's not always as easy to graph. There is a way to graph it just in standard form, but it takes a lot more work. But standard form can still tell us some things, okay? So standard form is something that looks like this. Capital A, X, plus capital B, Y, equals capital C. And there's some rules for what A, B, and C are. Standard form won't ever have any fractions. A, B, and C will all be integers. okay? We won't use any fractions so that you can't just look at it and see what the slope is. Okay, that number in front of A, or that number in front of X, that A coefficient there is always positive. Okay, and it's always set equal to a constant number C on the other side. If equations are given in standard form, you got to rewrite them in slope-intercept form by solving for y so you can find the slope. Okay, solving for y means get y by itself. So if you ever get an equation like this, we're going to get y by itself to find out what that slope is. All right, now we just talked about this on the other page, but I'm going to give you some examples here. A vertical line, vertical means up and down. Vertical line on the coordinate plane is always written in the form x equals a. Lowercase a just means the x-intercept. So for this specific example here, this is your line. It's kind of hard to see. This is an example of a vertical line. What would the equation of that be? Where does that line cross the x-axis? -1? Is that what you said? So my equation would be x equals -1. You can't put that in slope-intercept form. You can't, because it didn't have a slope, right? It's a vertical line. So that is the equation of that line. X equals -1. Horizontal lines are always in the form y equals b, where that's the y-intercept, just like it was in slope-intercept form. B was always the y-intercept in slope-intercept form. So this is my example here. That's where it crosses the y-axis. What would the equation of this line be? Y equals 3. Good. What's the slope of that horizontal line? What's the slope of any horizontal line? 0, right? So actually, I could put this in slope-intercept form. I could do y equals 0x plus 3. But what's 0 times x? 0, right? And what's 0 plus 3? 3. So it turns into y equals 3. So that actually is slope-intercept form. It just, you don't need to write the slope of 0 because it makes it go away. Okay, so let's look at some examples here where we have to change from standard form to slope-intercept form and find out what the slope is. And we're not going to do every single one of these because I'm going to save some time. You guys can do some of these on your own later if you want. But we'll do the first couple. So this is my equation in standard form. 2x plus 8y equals 56. I want it to be y equals mx plus b. I want it in that form. So I'm going to get y by itself. What's the first thing I should do there to get y by itself? Minus the 2x. Very good. And I'm going to show it on both sides of the equal sign there. It's going to cancel on the left, leaving just 8y equals. Can I actually do 56 minus 2x and get like 54x? No, I can't do that. Why can't I subtract those? Why can't I actually combine them? We don't know what x is. They're not like terms. 56 doesn't have an x. 2x has an x. They're not like terms. They can't be subtracted or added. So how should I write that side of the equation now? I could write it as 56 minus 2x, but don't I want it mx plus b? Negative 2x plus 56. Good. That's the better way of writing it. Good. Since 56 was a positive, we make it plus. One final step. The slope isn't -2 because y isn't by itself yet. What do I do next? You divide by 8 to get rid of that 8, right? So I'm going to divide everything by 8. I'm just going to show it twice on the right side then. I could do it all over 8 as one big fraction, but you're really distributing divided by 8 to both parts. So that's why I write it like I did here. So they cancel on this side, so we have y equals. On this side, that -2/8 we're going to reduce. Plus whatever 56 divided by 8 is. So let's simplify. What's -2/8 reduced to? -1/4. Good. And what does 56 divided by 8 become? 7. Good. So what is our slope of this line? Negative 1/4. That's the blank I'm asking you to answer, not the whole equation, just that blank, negative 1/4. So I probably could have even stopped early if that's all I need to answer. But knowing the full equation is a good idea sometimes. Okay, I want you to try number 2. Try and get y by itself on number 2 and tell me what the slope is on number 2. Okay, as we look at this, what should we get for our slope? Negative 2/3. All right, good. Subtract the 2x from both sides, end up dividing by 3. You kind of notice a pattern after a while. Subtract the x term, divide by the number in front of y. Subtract the x term, divide by the number in front of y. Okay, over and over and over again like that. Now, I do want us to go ahead and look at this next one really quickly. We're not going to go through the whole thing. We're just going to do enough to get the slope. When I move x to the other side, what do I subtract? Minus a 1x. If you write it that way, that's going to be a little bit easier. If you just write minus x, that's okay. But writing it as minus 1x might be helpful. I'll show you why. Then when I divide by 4, I'm not just dividing x by 4, I'm dividing that negative 1 by 4. So I get the slope is negative 1/4. When you write your slope in these blanks, when you write m equals, you're not going to write an x there. You're not going to say m equals something with an x. You're just going to write m equals a fraction with numbers. Okay? Now I want us to look at, we're going to skip number 4. And we're going to look at number 5 here and 6. These are special cases, right? So there's not a lot of work algebraically to do here. We're not solving the equation. They're already pretty simplified. Not a lot we can do. We need to recognize what the slope is of the original line here and know what to know what we would do with something later on. So what kind of line is always y equals a number? Horizontal or vertical? Horizontal is always y equals a number, okay? Because it crosses the y-axis. And here's where students tend to get confused and mix these up. Because you see y equals, you think y-axis, that's vertical. That's got to be a vertical line. It's not parallel to the y-axis. It crosses it. So that's got to be a horizontal line, okay? So y equals a constant number is always a vertical line. I'm sorry, I just said it wrong, said it backwards. Always a horizontal line. Okay, it's horizontal. Horizontal lines always have a slope of what? Okay, horizontals 0, right? Okay, so the slope is equal to 0. Think of it this way, y equals 2 could be y equals 0x plus 2, right? If you try and write it in slope-intercept form with that slope of 0, it works here because that simplifies. 0 times x is just 0. 0 plus 2 is 2. So horizontal lines have slope of 0. That's something you kind of just have to memorize. But this one, x equals negative 3, x equals a constant number, isn't horizontal. What is it? Undefined. It's vertical, so the slope is undefined. It's a vertical line, but you're right, the answer to the question, what is the slope, is undefined. Okay, because vertical lines don't have a slope, because you'd have to divide by 0. Sorry. Let's go ahead and go on to the next page. Okay, there's a couple pages here that we got to get through, but this is going pretty quickly because it's a review of what we do with lines. This is the big idea I want us to get from our slope lesson today. Determining whether lines are parallel or perpendicular is what slope tells us on the graph. That's really what I want us to focus on, okay? So when we look at parallel lines, I want you to remember this. Parallel lines are lines that never intersect, right? So these would be parallel lines. Okay? Perpendicular lines are lines that do intersect, but at a very specific way. Okay? Perpendicular lines are always going to intersect at a right angle. And there's a very specific relationship with their slopes. Now, we have a third option here. Lines could be parallel, they could be perpendicular, or they could just be neither. meaning they do intersect, but not at a right angle. Okay? If the slopes of, we're going to get to that part in a second. So we do want to look at the slopes of parallel lines, though. Two parallel lines on a coordinate plane are always going to have the same slopes, but different y-intercepts. That makes them different lines. So they're going to cross the y-axis at two different places, but they're going to follow that same rise over run pattern, so they never intersect. When one goes up 1 over 2, the other one goes up 1 over 2. Okay, they're like mirroring each other. Okay, anybody play basketball in here? Anybody have ever played organized basketball on a team? Middle school, club, anything? Did you ever do a drill where it was like a passing drill where you kind of shuffled down the court and you pass the ball back and forth? Well, you were moving on parallel lines. Okay, you were following the same path, the same rise over run slope down that court, passing the ball back and forth, right? So you would never intersect, you never run into each other, right? You kind of mirrored each other. That's what parallel lines do. Okay, perpendicular lines, since they do intersect, they don't have the same slope. They do not have equal slopes. Perpendicular lines on a coordinate plane are going to have slopes that are opposite, reciprocal. And I will explain what that means. Okay, that's two things. The connection of their slopes, the relationship of their slopes has to have two criteria. They need to be opposites of each other. What does opposite mean with numbers? How do you know what the opposite of a number is? Negative and positive of each other, right? Good. That's what opposite means. Negative of a negative, one is negative, one is positive. Okay, one is negative, one's positive. That's opposite. But reciprocal, does anybody know what that word means? We've been writing slopes as fractions, right? Reciprocals are flipped fractions of each other. So it would be like A over B compared to B over A. Reciprocals of each other. So what would the reciprocal of 2/3 be? 3 over 2. What would the reciprocal of 5/4 be? 4 over 5. So what would the reciprocal of 1/2 be? Just 2. 2 over 1, right? So then if I ask you, what is the reciprocal of 4? 1 over 4 is the reciprocal then, right? Because 4 becomes 4 over 1. And the reciprocal of that would be 1 over 4. So the reciprocal of a whole number is 1 over that whole number. All right? So the reciprocal of -3 here would be positive. Oh, sorry, this is missing a word. I actually want the opposite reciprocal. The opposite reciprocal of -3. -3, what's the opposite of negative? Positive. So the reciprocal of 3 would be 1 over 3. So positive 1 over 3 is the opposite reciprocal of -3. Okay, what is the opposite reciprocal of 2/5? -5 over 2. So you do the reciprocal first and then add the negative, or do the reciprocal and take away the negative. However you want to do that. Okay? So here's our example. What is the slope of a line that is perpendicular to this one? So first of all, what's the slope of this line? 1/4. So I want to do the opposite reciprocal of 1/4. What's the opposite reciprocal of 1/4? -4 over 1, or just -4. Good. Okay. If the slopes, so I'm moving on to this next line here. If the slopes of two lines are not the same and not exact opposite reciprocals, the lines are neither parallel nor perpendicular. They're just intersecting. So the options will always be parallel, perpendicular, or neither. If you show me that the slopes are not the same and not opposite reciprocals, you would better answer the question with neither when it's asking how they're related. I have it happen over and over and over again. Students see that the slopes are different and just automatically say perpendicular. And that's not the case. You have to look at the slopes and compare them. Are they opposite reciprocals of each other? and figure that out. Okay, so they will intersect, but not at a 90-degree angle if they're neither. Okay, so let's figure this out. Now, this is actually, I start right off with a trick question. Not a trick question, but not one that's super easy to identify. So if I give you these two, determine whether each set of equations are parallel, perpendicular, or neither. The first two equations I give you are special cases. The first equation, y equals -4. What kind of line is that? Horizontal, left and right, this way. Okay, you don't even have to write the words if you get them mixed up. Just draw a little example what the line would be. Does it go left to right? Does it go up and down? X equals -2. Well, that's the opposite of y, right? So whichever one y was, x, even if you have them backwards, you should still get this question, right? This is a vertical line. What's the slope of this first line here? Y equals -4. If it's a horizontal line, what's the slope? 0. What's the slope of that vertical line then? Now, are those the same slope? So they can't be parallel. But this is tricky. You would have to try and say one is the opposite reciprocal of the other to be perpendicular, but one's undefined. It's not neither. These are perpendicular. Think about it. One's horizontal, one's vertical. Aren't those always going to be perpendicular? Okay. Horizontal is always perpendicular to vertical. So I told you it was a trick question. Looking over here, number 2, x equals 4 and x equals -7. Are those both the same kind of line?
Oh, yeah.
They're both what? They both have undefined slope. So do they have the same slope? Yeah, so they're parallel. Now, you got to make sure they're not the exact same line. If they were the exact same numbers, 4 and 4, then obviously that'd be a problem. Are we getting that? Those are the trick ones. I got those out of the way first. Now the rest of these, they take longer, but they're not going to trick you. Okay, you're actually going to get a defined slope for each one of these, and we're going to compare those. So let's do number 3. Number 3, it says a first equation. Of course, I'm not just going to give it to you in slope-intercept form. We got to do some work first, right? We got to find out what the slope of line 1 is, so I got to put it in slope-intercept form. So I'm going to do 3x minus 4y equals 8 first. Let's fix that. What do I do first? Get the y by itself. How do I do that? Yeah, we subtract it to do that, right? And this is where it's very important. If you don't get these signs right, it's going to throw off your answer when you compare these two. So when I subtract 3x, what is left on the left-hand side of the equal sign? -4y. Please don't forget that negative. That is important. And the right side, we put the -3x first, and then it's plus 8. So now what do we divide by? -4 everywhere. Don't forget your negative when you divide. Cancels everything there, so we get y by itself. What is the simplified fraction for the slope of line 1? What's the slope?
-3.
But I had a negative on top and a negative on bottom.
Oh, positive.
Positive 3/4. Good. And what's the y-intercept? What's positive 8 divided by -4? -2. Good. So the slope of line 1 is 3/4. Now we can look at the slope of line 2. Fortunately, line 2, they go ahead and give you slope-intercept form. What's the slope of line 2?
Oh, no.
-4/3. Are those the same as each other? Are they opposite reciprocals? Yes, they are opposite reciprocals. You flip the fraction, one's positive, one's negative. So these are perpendicular. Okay? I want you guys to try number 4. Same way we just did this one, number 3. You're going to get y by itself on the first one and compare the slopes. Tell me if these are parallel, perpendicular, or neither. Okay, we should see these slopes then, right? Are they the same? Slopes are identical to each other. Right, now be careful. Sometimes that first slope you get, if you don't reduce it, you may not realize it's the same slope as the next one. Okay, but these are the same slopes, so the relationship would be what? Parallel, very good. All right. Now, we can also use just sets of points. I can give you 4 points in the coordinate plane like this, and we can find the slope of 2 different segments. And this is where it's going to come into play when we start graphing like rectangles, squares, parallelograms, things in the coordinate plane, comparing their opposite sides to see if they're parallel, that kind of stuff. That's where we're going with this. So we're going to determine whether each set of lines are parallel, perpendicular, or neither, just like we did. But all we're doing now is looking at the slopes. So back to what we started with, we're going to look at the slope of AB and the slope of CD. So we're going to group those two together and those two together. So we're going to look at their slopes. So remember, the slope formula we're using, I'll write at the bottom here, M equals difference of the y's, so y minus y, over difference of the x's in the same order. So like for AB, for the y values, we're going to do 3 minus 4. 3 minus 4 on top. Then I'm going to do 2 minus negative 1 on bottom. Now, some of you are going to get used to just changing that to a 2 plus 1 automatically, like this. What's 3 minus 4? Negative 1. What is 2 plus 1? So negative 1/3 is already reduced. That's your slope for AB. Then we're going to do the same thing for CD, the other 2 points. We're going to do y1 minus y2, so 3 minus 6, over x1 minus x2. Negative 5 plus 4, right? Because we do minus negative, turns into plus 4. What's 3 minus 6? Negative 3. And what is negative 5 plus 4? Negative 1. What is that reduced to? What is that reduced to? Positive 3, or even think of it as just 3 over 1, like that. Are those the same? Slopes? No. Are they opposite reciprocals? Yes, they are opposite reciprocals, so these lines are not parallel. Perpendicular. Parallel has those double L's in the middle, so you remember those are the ones that go together. They have to be the same. Perpendicular, every part of that word is different than the other. Okay, so you can remember the opposite reciprocal slopes. Okay, again, I want you to try this one on your own. Try number 6 on your own. Find the slope of AB and the slope of CD. Compare those and tell me the relationship of those lines. All right, somebody maybe raise your hand and tell me what relationship did you get? Ashley. Parallel, is that what you said? That's what I got too, because they both have a slope of 2, right? All right, both have a slope of 2. You reduce both those, you get 2. Good. So those are parallel. All right, we just got a couple more examples right at the top of the page here. Just 2 more. We're going to get through these because I do want you to see some other cases that you might get. There we go. Again, same idea. We're just going to group A and B together, group C and D together, find the slope of each one. Okay, we're going to do 8 minus 6 for the y values on top for AB, for the rise, and for the run on the bottom, negative 1 to 2, negative 1 minus 2. 8 minus 6 is 2, negative 1 minus 2 is negative 3, so that slope is a negative 2/3. Going kind of fast, but you can pause if you need to or copy down. Okay, so that slope's 2/3. Want to do the other one though. For my y values, 2 to 3, 2 minus 3, and then negative 1 to 3, negative 1 minus 3. We get negative 1 over negative 4, which is just 1/4. Are those the same slope as each other? No. Are they opposite reciprocals though? No, they're opposites, but they're not reciprocals. So they're not opposite reciprocal. They're not the same. What's the relationship? Neither. Because these are not opposite reciprocals, and they're not the same. So it's neither. All right, I said we had two more. That's actually all I need you to do. You don't need to do number 8. You can try it on your own if you want. Let me know and I'll check your answer if you want me to. But that's all we're doing in this lesson. Okay, we're using slope. We're looking at these graphs. We're doing those kind of things and going from there.